Okay, I didn't turn that on. I'll turn it on next time through. But notice the building coming down. Let's turn on the little dots now. And so I start taking the data just as it's about to fall. There we go. This little red dot's the one that I originally plotted. And all I'm doing is I'm putting a little marker on each frame to get a measurement. Now, to get them, this would measure it in pixels on the screen, but how do I know how actual far it is? What I had to do was get some sort of a known measurement. At first, I used the width of the building, but there's a problem. Look at this left edge. It's sort of foggy because of all that smoke, right? So I had to sort of estimate it. And I got sort of a number in the ballpark of free fall. But when, in August of 2008, so just a little over a year and a half ago, NIST, which is the government agency that was put in charge of investigating these building collapses, they came out with their quote-unquote final report. It was called their final report for public comment. So it's sort of like the next to the most final report, okay? And in that report, it gave the height of the roof line and it gave the height of the 29th floor. The top of the windows of the 29th floor is what they said. They gave those two heights down to the nearest inch. And I was able to use that data, convert it to meters, and put it in here. So now I had a good calibration. And what I came up with was that this corner came down essentially at G. My actual measurements, remember I said there's a little bit of round off and that kind of thing? My actual measurements are slightly faster than G. Now, I don't really believe there's some mechanism that's, rockets pushing it down faster than gravity. But let me say it is not almost at G. It's not sort of 90% of G. It's at least G. And there could be some, who knows. Just because it's tilting and things like that, there could be reasons this point is coming down a little faster. When NIST came out with this report, all right, you see how fast it's coming down, and here's the actual data. Let me just go ahead and put this on Analyze. I'll let you see for yourself. It's actually, if anything, it's a little bit more than G. So let's say fit a line, and let's say auto fit. And look at this number here. It says 1.03. This says E1. That means move it over one place. That's 10 point something. So the slope of that line indicates the acceleration. It's at least 9.8. It's actually a little over 10 according to this measurement. Okay? Now, with that in mind, with something so straightforward for somebody, now this is high school physics, guys. It's maybe not all of you had high school physics, but it's not like graduate level, it's not rocket science. It's something that a typical 11th or 12th grade student would be expected to be able to do on their own. Okay? Now, NIST's value for the fall of the building, the way they phrased it is it came down 40% slower than free fall. Now, in the first place, they didn't talk about acceleration. They talked about time. And they said the time it took to come down was 40% longer than free fall would have been. And so they're using sort of, in a sense, deceptive constructs to even talk about this. But what they're getting at is, hey, this is nowhere near free fall. And that's a problem. Okay?
So you're saying you're lying.
Oh, yeah, let's start with that. Okay, let's see what I'm saying. This part's going to be a little video, so I can rest my voice for a second here. And this is probably the video that, if I'm famous, this is the one that did it. But it's not me. Hey, I'm not the star of this show. Star of this show are these guys from NIST. You'll see what I mean. Now we'll see if these speakers are turned on. In August 2008, after a 7-year delay, NIST, the government agency charged with investigating the World Trade Center collapses, released the draft of their final report on the collapse of World Trade Center Building 7 for public comment. In that report, they claimed that the time for the building to fall, the first 18 stories, that's the part of the collapse visible on many videos, was 40% longer than it would have taken had it been in free fall. I responded with a video posted on YouTube called WTC 7 in Free Fall.
in which I showed that for approximately 2.5 seconds, Building 7 fell at a rate indistinguishable from free fall. Furthermore, in that video, I showed that NIST's methodology was not a valid way to analyze the true motion of the building. NIST's measurement was not just wrong, it was fraudulent. Then on August 26th, NIST staged a technical briefing in which engineers and others with technical credentials could pose questions. I'm a high school physics teacher, so I figured I would be excluded. However, I went ahead and registered, citing my membership in the American Association of Physics Teachers as my professional affiliation. By the way, I am not speaking for AAPT. That was just my passport into the briefing. To my surprise, my credentials were accepted, and I was able to pose a question. Here's a little of how it went.
Our next question comes from David Chandler of the American Association of Physics Teachers. Any number of competent measurements using a variety of methods indicate the northwest corner of WTC 7 fell with an acceleration within a few percent of the acceleration of gravity. Yet your report contradicts this, claiming 40% slower than free fall based on a single data point. How can such a publicly visible, easily measurable quantity be set aside?
Can you repeat the question, please?
Sure. Any number of measurements using a variety of methods indicate the northwest corner of WTC 7 fell with an acceleration within a few percent of the acceleration of gravity. Yet the report contradicts this, claiming 40% slower than the free fall based on a single data point.
Well, first of all, gravity is the loading function that applies to the structure, applies to every body, all bodies on this particular on this planet, not just in ground zero.
Whoa. I'm used to responses like that on a physics exam when a student hasn't even bothered to open the book. This is NIST speaking, so let's continue.
The analysis showed there's a difference in time between a free fall time. A free fall time would be an object that has no structural components below it. And if you look at the analysis of the video, it shows that the time it takes for the 17 for the roof line of the video to collapse down the 17 floors that you can actually see in the video, below which you can't see anything in the video, is about 3.9 seconds. What the analysis shows, and the structural analysis shows, or the collapse analysis shows, that same time that it took for the structural model to come down from the roof line all the way for those 17 floors to disappear is 5.4 seconds. It's about 1.5 seconds, or roughly 40% more time for that free fall to happen. And that is not at all unusual, because there was structural resistance that was provided in this particular case, and you had a sequence of structural failures that had to take place, and where everything was not instantaneous.